Okay, according to the doohickeys, it says that we are live on my end. All right, let me get a test from you now.
Check, check, 1 2 1 2.
Looks like we have audio. That is good. Audience, you can correct me if I'm wrong on that, but you appear to be getting audio from both of us, which is either the most amazing thing ever or the most horrible thing you could possibly imagine in your entire existence. So, with that, I'm going to say hello, everyone. I appreciate all of you for being here today. So there's going to be two different live streams going on, one on my side and one on the other side. So let me just introduce myself, and then I would ask that you do the same.
Sure.
My name is Red from the YouTube channel Red's Rhetoric. I do a whole bunch of different things, so like record rocket launches and talk about flat Earth for some reason. And I decided to have this conversation talk about our time in space and the feasibility of satellites. I think it will be a great conversation. For my audience, could you introduce yourself, tell people who you are, what you do, that kind of thing?
Sure. My name's Jim Bob. My channel is made by Jim Bob, and I have an Instagram account as well. I'm primarily a cartoonist. I do satirical cartoons and stuff with culture and politics, but I get into theology. I get into different topics, and one of those topics is space and the concept of space, the history of the concept of space travel. I'm interested in some of that. And I just kind of explore this stuff, and I try to do it in a humorous way. Sometimes it's combative, but ultimately, I'm just interested in the variety of topics. This is just one of those topics.
Excellent. All right. So let me go ahead and break the ice, and thank you very much for agreeing to this discussion. Sure. So to break the ice, I was informed by some individuals on Twitter that you are skeptical as to our success in space, primarily in regards to like satellites, orbital satellites and stuff. Is that a fair assessment of your position?
Yeah. Yeah, it's like kind of like inquiring about what the claims are, what the purpose of them are, what the extent of their capabilities are. It's pretty much an open-ended inquiry where I start from skepticism.
Okay. So I guess I'll start with the obvious question. Do you believe that satellites even exist?
Yeah, to what extent, I'm not clear on. I know that the early programs and still programs today do use balloons, and that comes up a lot. Now, that's not a defeater to orbital satellites just because that exists, but it is interesting that 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 aspect exists. That format of a satellite exists, and it makes sense to me to create some sort of system of a connected network of information and data through ballooning. And not only that, that ballooning would allow for maintenance because you can habitually land these things with precision safely. Whereas the alternative, where there's 11,000 some, correct me if I'm wrong, 11,800 satellites from various sources in perpetual orbit. I didn't verify that, so I'm not going to deny it or affirm it. I just didn't. There's no way for me at this point in my inquiry to affirm it. I just kind of look at it like, okay, well, what can I observe all of them? Can I examine all of them? And I don't know the answer to that.
So basically, you are aware of what is typically referred to as satelloons.
Mm-hmm.
So satellites that hang from high altitude weather balloons, and you're familiar with those. But as far as the orbital variety of satellites, you
Mm-hmm.
are, I guess, unconvinced of their existence and or of their feasibility.
Yeah, like I would say their existence, or to what extent they do exist. Is it the number that's posed? What is the when someone says there's a satellite in space, are they specifically saying it's orbital, or are they including the thing that's also a satellite that's attached to a balloon? I don't know that. I don't know how to sift all of that out, but it comes into my mind when I question it. So
I
yeah, to that
understand.
extent. And then as feasibility, I think of the question of like a really basic question, like what is it that an orbital satellite does that's worth having that as a system that a lower form of a satellite that's just floating can't do? And further, what is a satellite doing? What is it capable of that can't be replicated or done better on the land itself?
Well, if you wanted to talk about like what they can do,
Hmm.
that would be different from like let's say a Satelloon.
Okay.
A Satelloon would be very unpredictable in terms of the weather. It's always going to be at the mercy of the winds in that particular area that you happen to launch the thing, and you don't have that kind of predictability when it comes to an orbital satellite that would be unaffected by such things. So let's say you are using satellites for GPS. In order for GPS to work, the satellites would have to be in a certain configuration to make sure you have complete coverage all over the planet. Otherwise, if they were all bunched up in one place or another, you would have a stronger signal in one location as opposed to a different location, which would be a weak signal, and it would just be totally at the mercy of the wind. Whereas if you had GPS satellites that were actually in orbit, they would be spaced apart continuously because that's how you literally made them orbit. It's kind of
Okay.
like clockwork on that front.
Okay, well, then would you say, in addition to avoiding weather complication and inhibitions, would you say, is there something specifically technologically that the satellite does that a lower altitude machine or a land machine couldn't replicate?
I'm sure there's a lot of things that can be replicated. I think the way that or the reason why they would use satellites is to lower the amount of infrastructure that's needed. So, for example, if you are a certain altitude over the Earth, you can see a certain amount of that Earth. Whereas if you're in a satellite that is way further away from Earth, you can see a lot more of the surface area, and therefore your area of coverage would be increased, and you just lowered the amount of satellites that you would need to accomplish that same exact goal.
Okay, but what is it you're seeing in that example then? Like,
So
what's the
if
data you're seeing?
Well, it's basically a question of geometry at that point. So if I am looking at a sphere.
Mm.
So if I'm looking at a sphere and it's really close up, like because Satelloons would only go as high as your typical weather balloons. So what is that? About 20 kilometers or so, 30 kilometers, something like that. People in the live chat, if y'all can check out what's like the maximum altitude of a weather balloon, because that would be the maximum altitude of one of those balloon satellites as a consequence of that. So you would then have a total coverage surface area. Let's say I'm just pulling a number out of my ass here. Let's say you can see 100 kilometers in all directions from that particular satellite. Well, if you go to geostationary orbit, you just increased your surface area by thousands of kilometers. And that surface area being covered by a single satellite as opposed to many smaller, more numerous satelloons, you just, increased your coverage and you lowered the amount of money that you'll be spending. And also the infrastructure just would be a lot easier in that case.
Okay, but wouldn't well, the question is, okay, so if granted surface area, but surface area itself, I don't know the value of just surface area if not the data that's assigned to the surface area. So I'm asking, what is it the satellite is doing that can't be done? Like you're saying that it's higher, therefore it has a greater vantage point, right? A wider resolution as opposed to a closer resolution for what it's looking at, right? For what its eyes and ears, so to speak, are
Yeah.
are taking in. But I'm asking, what is specifically the advantage of wider surface area itself? What's the data that it can gain that the lower versions can't piece together on their own?
It's a question of efficiency. You can do the exact same thing with, like, let's say undersea cables. You don't need Starlink to have
Sure.
the internet globally connected.
Hmm.
You don't need satellites to predict the weather, for example. You don't need the International Space Station to do science. You just don't. But it's a question of efficiency. And wouldn't it be great for us, instead of linking a whole bunch of separate radar stations which do have gaps in between them, wouldn't it be great to fill out those gaps with a overarching view of the planet so that we can make better models for weather prediction, like, for example, what we get with the Himawari satellite, or with the Epic satellite with the Discover, or I'm sorry, the Discover satellite with the Epic camera. All of these are tools that we use because they are more efficient. And not only are they more efficient, given the fact that they have a wider view, there's less gaps
So,
in
you-
its
so,
service.
so weather is your primary distinction between what a satellite gains in a wider view that lower things that are just interconnected through some sort of system can't see. Is that what you're saying? That
Not
weather
not
is,
just
is the thing?
weather, not just weather, just efficiency all over, because it's all about filling the gaps in between. So let's hypothetically say your undersea cables get damaged by earthquakes, for example, or they get damaged by some other natural disaster here on the ground. Satellites are impervious to that. They don't care about the weather events. They don't care about earthquakes. They don't care about any of that stuff. And also, given the fact that they don't care about that stuff, you have redundancy built into the system. And also, on top of that, given the fact that satellites require a lot less infrastructure to operate, you actually end up saving a lot of money in the long run.
Okay, so you're saying
They're
it's
they're
a fine.
cheaper. They're cheaper is what I'm trying to
Okay,
say.
it's financial advantage in
Yes.
addition to you can look at weather from a larger
It's
vantage point.
it's a financial advantage, it's a infrastructure advantage, it's an efficiency advantage, and not just science but also regular communication. That is correct.
What's regular communication?
So that would be like your internet connectivity, your voice connectivity,
Is
TV, radio. Sirius XM even has their own geostationary satellite, and
isn't it the case that over 90% of our communications is hardwired underground
I would
cable?
say the vast majority of our communication is hardwired.
So what isn't that contradict that it's more efficient to do communication through satellite? If the majority obviously of our communication is hardwired, then it's more efficient to do hardwired.
No, not entirely, because even though most of our connectivity is hardwired, not everyone lives in the same type of environment that we do. Try getting a hardwired connection in Antarctica. It's not a good idea. Try getting a
Okay,
hardwired
so
connection in the middle of the ocean. Not a good idea. Try get a
right,
hardwired connection on a plane.
yeah.
Not a good idea.
I understand that, but those are exceptions, correct?
Yeah, but you want to fill in the gaps. The whole point of us having satellites is because there are exceptions, and we want to make sure that those exceptions are accounted for.
Well, I'm saying exceptions are more so if they're exceptions, then they're not necessarily more efficient. You're just saying that the primary source of communication is hardwired ground level tower communication, and then the satellites are for exceptions. But if you're saying that they're for exceptions and they're filling in the gaps, they aren't. Satellites compared to ground aren't more efficient then.
No,
That
they're
would be
more
false.
efficient for certain aspects.
For
Like, for example,
exceptions. For exceptions.
no, for example, GPS. Is GPS an exception in your view?
Is what? Say that again. Sorry.
Is GPS navigation an exception in your view?
An exception to ground?
Yeah.
I don't know if it's a necessary exception. I think that navigation could be done through a modeling of the geography as opposed to something that's like constantly rotating around the Earth and telling you stuff. Because once you have a model, is it not correct to say that once you have a model of the Earth, assuming that continents don't drastically change, navigation should be pretty much set in motion from a model. You don't need the physicality of the ongoing live data to do navigation once you have a model of Earth?
Yeah, well, once you have a model of Earth, that's great, but you also want to be able to navigate throughout that model in the most efficient manner. And what we found out is that GPS satellites provide that more efficient manner, because you have one satellite that's able to service thousands upon thousands of people in the continental United States alone, if not millions of people within the continental United States alone, I should say. You can then, like I said, lower the amount of infrastructure that you're actually dedicating to the cause.
But isn't
So,
isn't GPS tower based though? Like ultimately,
no, it isn't.
it's not tower based.
No, it's by satellites. You can actually see GPS satellites. If you go to a website called Heavens Above, it'll actually map out where the GPS satellites are in the sky. It's what we use for our tracking software with telescopes here on Earth.
I thought GPS was tower triangulation, and that you fill in the gaps through triangulation, which happens to be very effective on the ground.
It's not. No, it's not tower
No.
triangulation. You could do it that way,
Oh,
but it's not something that is the most efficient way of doing it.
okay.
And the idea is that when you look at, for example, our weather models, our ability to communicate instantaneously all over the planet, we don't just rely on one technology. It's foolish to put all of our eggs in one basket. We want to make sure that we have a cumulative effort here to achieving a particular goal. And if the particular goal that we're after is great predictive capability, great reliability, so that if one system goes down, we have another as a backup, and also given the fact that it is in many industries a lot cheaper to do it this way, then satellites pose a great thing to invest in. This is why SpaceX is launching, an absolute fuck ton of them. Jesus Christ. They're launching, almost every week, 50 satellites at a time. And they're not doing that because it's unprofitable. They are making money from that endeavor.
Okay, so let's talk about the maintenance comparison. So what is the maintenance of a satellite rotating in space? What is the maintenance? What's the
There is none.
there's no maintenance.
No. They have a lifespan of around 10 to 15 years. If you are talking like, I believe this is also the case for Starlink, although I could be wrong on that. But I do know that for geostationary satellites, we have a lifespan of those satellites of between 10 to 15 years, depending on the vendor.
Okay, so things just don't break. Satellites just don't break.
No, they're designed to be very reliable. In fact, the overwhelming majority of them outlive their original planned life expectancy.
Okay, and so when they do lose their life, do you deorbit them or keep them in orbit?
You can deorbit them, yes. It all depends on which orbit they are in. And so this kind of is going
Lower or higher? Got it.
yeah, so if you're in low Earth orbit, then it would be a lot easier to deorbit a satellite, whereas if you're in a higher orbit, you don't deorbit it at all. What you do is you boost it up into what's known as a graveyard orbit, where it's out of the way of functioning satellites.
Okay, and are all of the different phases of, or let's say levels of orbit, distance, I guess we can call it, altitude or whatever, from the surface, do they all require ongoing boosters to keep the velocity in relation to the fallingness, the falling around the Earth, the velocity?
You're talking about station keeping fuel?
Yeah, like which satellites, if you just leave them alone, will eventually meet friction and eventually lose speed and fall? Like which satellites are those?
Not in geostationary. In geostationary orbit, like let's say, and I should be very very clear here that if a satellite does fail, it's very very rare that it does, but it does happen. You are correct. But even if you were to completely wipe out the memory of a satellite and it just stopped working, it wouldn't fall to Earth in geostationary. It would stay there for millions of years.
Millions?
Millions, yes.
Okay, so are there any satellites that, if not kept up to speed or velocity, will fall?
Those would be low Earth. I know that it happens with the International Space Station because it needs periodic reboost because it is dealing with the friction of the upper atmosphere. But the higher up you go, the less of that friction you're actually dealing with. So, for something like Starlink satellites, they are purposely placed at a low enough altitude where you will experience some atmospheric friction. Now,
Okay.
keep in mind, we're talking about molecules of air here, so it's not a lot. But eventually, you will need to do a reboost.
Okay, so there are essentially, it says about 11,000 something satellites, and 5,000 of them are low orbit.
Mm-hmm.
So what I'm asking is that for satellites that require a booster, you're saying that the intermittence of needing a boost is few and far between, or is there a set amount that it does need a boost, and how do you know it needs a boost?
You would look at its altitude relative to the altitude it's supposed to be at. Your orbital velocity is actually determined by your altitude. The closer you are to Earth, the faster you will orbit as a result. If you're further away from Earth, then the slower your orbit is going to be as a result. And
So
so you
who?
can
Gotcha.
look at these changes and see if they are outside of a particular threshold. Once they approach that threshold or get past that threshold, you can then activate your reboost to get it within your acceptable range that you
Who
predetermined.
who activates the reboost?
I believe it's whoever is the owner of that satellite. So, for example, SpaceX is doing continuous monitoring of their constellation, they call it. And if any of these satellites go beyond a particular threshold, then they are the ones that command the satellite to do the thing it needs to do to reboost itself.
Oh, so do you get fined if you don't reboost your satellite?
No, you just lose a satellite or it falls into a different orbit that you may not have wanted it to be in the first place.
Oh, okay. So yeah, it seems like I'm just wondering, like, if there's enough private satellites that there's some sort of obligation to stay reboosted, to keep your boosters up and up to date, because if it's the case that it does need a boost, then what you're saying is that satellites don't come with something that can tell you its own altitude and then boost itself, right? Just like at home, like an at home booster. Um,
I'm assuming that these telescopes are, or not telescopes, these satellites are very advanced, and so I'm pretty sure it knows its own altitude. I'm pretty sure it knows its own orbital velocity,
so then it would
and so
never lose altitude then, because if it knew, it would know to keep its altitude. So this notion that there are some satellites that lose altitude, tell the owner, and then maybe the owner from their satellite app gives it a booster and it puts it back up to its correct altitude. But then if you're saying, if these satellites are so advanced that they know their own position geospatially, altitude and attitude, that they self-correct, but then aren't you saying that, now you're saying, not that it's a contradiction, but now is there a variety of satellites, and some require the owner to hit the booster and some just never uh, move they never get out of improper altitude and attitude?
what I'm saying is that there's more than one way to skin a cat, and whether SpaceX has to take manual control every now and then or it's something that's completely automated, either way, a reboost is done. And when that reboost is done, they get placed right back into their proper orbit, and then life goes on as normal.
Gotcha. And then there's a life, a shelf life of, I guess, what's the fuel for satellites to reboost?
I think it's like what is it? Hydrazine or something like that. It could be RP1 kerosene. It could be cold gas thrusters for all I know. It could be xenon. So there's so many different options in that case. I don't know. It depends on the manufacturer of the satellite and the satellite itself.
Yeah.
What their requirements are, how much delta V is needed for its particular lifespan, what orbit is it going to go into. There's so many different answers to that question.
Okay, and then deorbiting is fascinating to me as well, because uh, Also the same question of like when do you know to deorbit something and why, is one question I would have. Like, why does something get deorbited or not deorbited? What would be the reason for that distinction?
If it no longer has station keeping fuel, then it would have been considered to have lived its life expectancy, because its life expectancy is determined by the amount of station keeping fuel it has. And so once you reach a particular threshold and you know you have just enough to deorbit to not leave space junk, then that's when you would implement your deorbit program on that particular satellite.
And there's are there several ways to deorbit or just one way to deorbit?
Unless you're going to crash into something, the way that you deorbit a satellite is to slow it down. So you slow down your satellite, and that's how you deorbit a satellite.
You slow it down with the boosters.
Correct.
So okay, so then when you slow it down, um, eventually it just falls to the earth, or
Correct. If you slow it down, it falls to the earth. That is correct.
and then who determines how and where it falls?
I believe there is a point over the Pacific called Point Nemo. It is the furthest point from land, and I think Point Nemo is also called like the satellite graveyard for a reason. The one thing that companies don't want to do when they're deorbiting their satellites is to get sued by anybody, and so they try to deorbit them in the middle of the ocean where they know no one's going to be around to potentially get injured by debris. Not that much debris makes it to the ground, but they want to play it safe, and so usually they will deorbit it over in the middle of the ocean. That's usually how that works.
Oh, in the ocean. Okay.
Correct.
And so it also says that when people deorbit, they say that the satellite itself disintegrates.
Yeah, most of it does disintegrate. Absolutely.
So it's not it's not a satellite landing in the ocean. It's a disintegrated satellite, or
They deorbit it over the ocean. Whether or not it hits the ocean is a totally different question.
yeah, that's what I was thinking. Is like if it's just like turned to dust level disintegration, I guess it's just a matter of where to properly litter the disintegrated thing. But certainly, if it disintegrated coming through the Earth's atmosphere to some negligible amount of dust, then it wouldn't really matter where it landed. It would just be like, mommy, look at that like that weird dust cloud. But I'm not certain to what extent when they say, because what I read is it disintegrates, like actually disappears from the friction of the atmosphere coming down. So I'm wondering,
Correct.
like,
It does.
well,
It does. Disintegrate, but there's always a chance that a screw or whatever could get through and everything like that. And so it's a precaution that they're taking.
okay,
They're very, very confident that most, if not all, of the satellite will disintegrate upon reentry, but it's always a precaution, a precautionary move to deorbit it over the ocean where there is no population centers.
got you. So I mean, technically, when it disintegrates, it could be picked up by wind and miss the ocean, or
No, not like that. I mean, if it turns to dust, then I guess it could go with the wind at that point. But the harder stuff would of course go through the wind.
oh, okay. Do you know how many? I don't know this, but do you know how many satellites relative to how many exist are deorbited?
That I don't know the exact answer. What I do know is that SpaceX and their Starlink is relatively low Earth, and they have thousands of satellites in low Earth orbit. And the going component, or the going model of their plan for Starlink, is to have each and every single one of those satellites to have the capability to be deorbited. So I do know that for SpaceX, at least with their thousands of satellites, it is in the game plan that each one of those satellites will, live throughout its useful lifetime. So whether that's 5 years, 10 years, 15 years, whatever the case may be, I guess it depends on which version of the satellite they're actually going on. Some may have longer life expectancy than others, but all of them are made with the understanding that they will be eventually deorbited.
Gotcha. Because it seems like there were just because the same reason there's people, organizations like Green, like the Green Party, who are concerned with the environment. Is there like a counter space satellite what would you call it? I don't even know what you'd call it. Like an organization that just got that's like anti-satellite. I mean, is that a
Not,
thing?
yes, I have. They're called flat earthers.
No, no, not the denial of satellites. The people who are against it because of they can call the space like sort of an environmental problem. Like,
Yes,
are those people?
absolutely. Yes, they're called flat earthers
Oh, the
because
same people. Yeah.
yeah, they are the exact same people because they don't believe that satellites make it to space. They think they immediately get ditched into the ocean and thus litter.
Oh, that's from that view. I'm talking about space, like the environment in space, like assuming that there is 11,000 things in there that eventually will turn to junk if there's any concern of what that could mean. I mean, it's essentially like obviously it wouldn't be a problem now considering the amount of space available, but
As far as any sort of like like you're thinking of like a PETA type organization, no,
yeah, yeah,
I don't believe one exists.
right.
According to my live chat, a good friend of mine by name Astronomy Live, who I will be bringing up in a moment, he says, "quote Starlink satellites are designed to be less resilient to reentry in case of unintentional deorbits, such as the recent Falcon 9 second stage failure." So yeah, recently there was a Falcon 9 that launched. First stage performed as it should, but the second stage had a little bit of an oopsie. And they were able to get to orbit, but unfortunately it wasn't a high enough orbit where they wouldn't immediately get deorbited by the atmosphere. So they didn't get high enough to get over the atmosphere and thus were deorbited. And as far as I'm aware, it didn't cause any issues whatsoever besides losing a shit ton of satellites. So that
Yeah.
sucks for them.
Yeah, yeah. So I mean, I guess I'm looking to the graveyard and like, what's the rapid production and deployment of satellites, and is there a threshold at which like, you could be like, oh, you're creating an actual physical layer, um, in space, like an actual physical wall at some point. I mean, not in our lifetime, but that seems to be a logical consequence.
Well, yes, if eventually if you just keep adding more and more satellite to our sphere of influence, eventually you will come to a point where there's just way too many of the damn things. I totally agree with that. But we haven't hit that yet. I do know that a few astronomers are very, very angry with the amount of satellites that are being put up there because they're
Oh,
constantly
right.
getting photobombed within their shots. And yeah, that does suck for them. But for just the feasibility aspect, there's plenty of room as of right now, and I'm pretty sure they're going to fill every single nook and cranny because the economics have spoken and the economics work for what they're trying to do. Because SpaceX is not going to be the only game in town when it comes to their constellation. Even Amazon, of all people, is trying to launch their own constellation, and they've contracted 3 different companies to send up their satellites.
Hmm. Do you think there's going to be a space tax?
I would imagine eventually, but I don't know if it has happened yet.
And then let's say I raised some money, I wanted to launch a satellite. Do you know what's required for that to happen?
As far as I'm aware, you would just have to contract a company to, one, either build the satellite and they do all the paperwork for you, or you can get in contact with NASA directly somehow. I've never launched a satellite, so I don't know what paperwork is required. But the one thing that I do know about the satellite deployments is that you would always go through a launch provider. And that launch provider would be able to guide you through the process. So if you called them and said, okay, I have this particular satellite I want to place in this particular orbit, what do I need to do to make it to that particular orbit? They can walk you through the process.
Gotcha. Yeah, because that's what I was wondering. Is there any private company that's not the main authoritative launchers that can start launching satellites
Well, I don't know.
themselves?
I don't know what you mean by authoritative launchers. There are private companies launching all the time. For example, SpaceX, like I mentioned previously, ULA, which is United Launch Alliance, Rocket Lab, which is a CubeSat launcher for now, but they will be launching the Neutron rocket, which is a little bit bigger. There's also Blue Origin. That's Jeff Bezos, the guy that does Amazon. He has his own rocket company called Blue Origin. He's going to be launching the New Glenn. He was actually contracted to launch a couple payloads to Mars. That should be happening in October relatively soon.
Mm.
Ariane Space, I know, is through ESA. I don't believe that is a private company. I think that is government, although could be wrong. Please correct me if I am wrong on that. And there are, and one more private company that I know of that has gone orbital, which is Firefly, Firefly Aerospace. They recently launched and put a few satellites in the orbit. So all of those are private companies. They are not through NASA. They're not through the government. They do get government contracts, but they're not government themselves.
Oh, what did you say? He's gonna. What did you mean by payloads? Jeff Bezos is gonna do what to Mars? What is he gonna deliver? To
Payload
Mars?
is a another name for a satellite. So, for example, a payload is anything you put on the rocket. So, for example, Elon Musk launched his Tesla to space. If you remember that, that was the payload for the Falcon Heavy.
Is that trackable? Can I see that with a good enough telescope? The
When
car.
the next time it flies by Earth, sure. If you want to see what other people were able to capture with it, I would recommend tuning into Astronomy Live.
Oh
Astronomy
yeah, I know
Live
that
was
channel.
actually able to track the space Tesla, let's call it.
Yeah.
Astronomy Live was able to track the space Tesla as it left the sphere of influence of the Earth.
Mm.
So
And
that
they lost it, or
no, it was meant to go out. They know exactly where it is. It's just not close enough to Earth to be seen with a telescope right now.
mm.
So, oh yeah. So according to Astronomy Live, he says, "quote I tracked it out to 8 times the distance to the moon. Nice job, good sir." Astronomy Live, if you would like to do me a favor, you have a wrench in mind. Go ahead and copy and paste a link to that, and I'll share it. That way, I want people to be able to see that awesome tracking that you did with your telescope. But yeah, he tracked it out to 8 times the distance to the moon. So, yeah, that's pretty awesome. But if I can kind of go back in, when you're asking all these questions, we're talking about the economics and who has
Yeah.
what contract and how. But at the end
Yeah.
of the day, I still have one question that I want answered, and that is, do you believe that satellites in the orbital sense actually exist?
Um, I mean, I could assume that they exist. I just don't have a great reason myself personally, other than just appealing to people saying so.
All
I
right.
mean, that's all I got.
So would you accept measurements of, like, for example, if I was able to measure the altitude, the size, and the speed of the International Space Station, for example, would you accept that as evidence and or proof, depending on how you define proof, evidence and or proof of the existence of satellites?
No, I would say that it's proof and measurement of an object.
Yes, but an object that is traveling at 4.7 miles per second, which is orbital velocity, at an
Oh.
altitude of 250 miles, which is space, and
Mm.
it is the size of a football field, which is what the space station is.
Yeah.
So I would be independently able to do all of that. That on its own wouldn't be convincing to you?
Not necessarily. I don't think it follows that if you can track and predict the observation of an object in space, that it follows that there's all these satellites doing what they're doing. It doesn't necessarily follow, no. So I wouldn't take that because it's not a logical follow.
Well, that's the thing. We're not making a prediction. That's the
Well,
thing.
it's like basically an inductive. You're just doing inductive reasoning, right? You're saying that, well, if I see this out there and I could track it, therefore all these other things exist. You're saying it's reasonable to come to the conclusion that all these other things exist if this one thing exists, right?
I'm not making that jump. I'm speaking specifically about the International Space Station. We'll get to the other satellites later, but just for this particular conversation, I'm just talking about one particular satellite, which is the International Space Station. So, if I was able to show you measurements where myself and Astronomy Live, because this is exactly how we did it,
Yeah.
where we independently, outside of NASA, outside of any government agency, we were able to independently verify the altitude, the size, and the speed of the International Space Station.
Yeah.
Would that be good enough for you just for the International Space Station? Not talking about the other satellites.
No, again, I would just conclude that there's an observable object in space that's moving in a certain way. I
Okay.
mean, that would be a fair conclusion. I mean, that wouldn't. I mean, that's exactly what you'd say, right? But you're saying, well, this thing is this other thing. What something is a different. Do you agree that what something is a different question as how something is?
Depending on how you're phrasing that, yes, it is.
Sure. Well, there you go.
But the deal is the exact same, regardless if it's a functioning thing or
Mhm.
something that's in the shape of a giant pair of gonads. It doesn't matter because an object in orbit is still an object in orbit. Whether or not it's a functional satellite is
Right.
a different question. I'm saying that
Yeah.
there's something there in orbit
Well, yeah,
anyway.
I would say that would be begging the question as far as what orbit is concerned. So, it possible that there's an apparatus that you're observing that has a particular flight path that's predictable, that
You
isn't necessarily at the effective orbit, but rather some sort of flight
No, it wouldn't be able to be within Earth's atmosphere. Not at all.
that you can't that you couldn't that it's not. You're saying it's logically not possible for something to be in flight.
Yes, I am saying it is actually impossible for it to be any sort of flying apparatus. Flight is impossible at those speeds. When we measured the altitude, size, and speed of the International Space Station, do you know what speed that we were able to measure?
No.
We got it at 4.7 miles per second. Now, let me put that into different numbers. That's 17,500 miles per hour. If
Okay.
you were to go that fast within Earth's atmosphere, you would rip yourself apart. Not only that, but with the telescopes that we
How fast
were
is that in miles per hour?
17,500 miles per hour.
Isn't the escape velocity for Earth 25,000 or 25,000 miles per hour?
Yeah, but we're not trying to hit escape velocity.
I know, but you're saying nothing could fly that fast, but escape velocity assumes flight.
Escape velocity assumes velocity,
Yeah, yeah,
not.
no, you said something can't fly if it's going that fast, and I'm saying, well, if escape velocity is a thing, and you have to have some sort of apparatus or propulsion to get you to 25,000 miles per hour, that's a contradiction then.
No, it's not. I
Yes,
don't.
what do you call it? What do you call it going from 10,000 miles, 1,000 miles per hour to
I
25,000 miles
think you
per hour?
misunderstood what I'm talking about here. Let me see if I can repeat so that we're not talking past each other. When I say you can't go that fast in Earth's atmosphere, what I'm saying is you can't go that fast in Earth's atmosphere. You can go that fast when you're in an environment that you're not being continuously slowed down and dragged down by the atmosphere. That's why,
Doesn't
satellites
it?
are at the altitude that they are. You want to get
Uh,
over the atmosphere so that you can go that
I
fast, so
just,
that you can hit orbital velocity.
isn't the Earth's atmosphere extend to the moon?
Not in the way that you're probably thinking. No, it
So
goes from 1 bar of atmospheric pressure and then it gets thinner and thinner and thinner the higher up you go.
so
The
wait,
article that you're probably referencing that says the atmosphere extends all the way to the moon, we're talking about each individual molecules, which is not the same as what we have
okay.
here
Let me try to
in
let me try to
in an airplane type of environment.
let me try to give back to you what I think you're saying. You can correct me. You're saying that the ISS, as you're referring to, that's moving at 17,500 miles per hour, right? You're saying it's impossible for an object to move that fast if it's not in orbit, right?
Yes, it has to be in orbit outside of the Earth's atmosphere.
Okay, where is there a defined line of where the Earth's atmosphere ends?
The accepted line for space is about 100 kilometers. After that, the amount of speed that you would need to generate lift on your wings would be roughly equivalent to how fast you would need to go to be in orbit anyway. So at
Okay.
that particular altitude, you wouldn't be able to generate enough lift before you hit orbital velocity and are essentially in orbit anyway. So at that altitude, your wings essentially become dead weight. They become useless. Might as well get rid of them.
Okay, so then my question is, what's happening then between going 17,500 miles per hour and reaching 25,000 miles per hour? What's happening in between those two speeds?
Well, there's nothing because the International Space Station doesn't go
No, I'm not.
25,000
I'm not
miles an hour.
asking if. No, I'm not asking if that's going 25 miles per hour, 1,000 miles per hour. I'm saying for something to escape the Earth's gravity, right? The pull, they need to be going 25,000 miles per hour. Correct?
I believe so, but they're not
Okay.
they're not escaping.
I know. I'm asking you a question. If
Yeah,
you
but
wanted to escape, right?
yeah,
I'm
but
asking.
all due with
You're
respect,
you're not
this
answering the
question.
question.
Yeah, but all due with respect, this question is irrelevant to the International
It's not
Space Station.
irrelevant. It's actually it's relevant to the topic itself, which is the maneuvering and the ability to do things in what you call space, whether it's 60 miles up, 250 miles up, or further than that. I'm actually talking about what is the engineering in play. If you said an object, because your statement is this, an object that's moving as fast as the ISS can't do that unless it's in orbit, right? That's your statement.
Yes.
I'm asking you, what is it? What do you call it when an object goes from anything below 25,000 miles per hour and it reaches 25,000 miles? What's happening? I'm actually asking you that. What's happening such that an object goes from 10,000 miles per hour to 25,000 miles per hour? What's happening?
An acceleration? I actually don't know what you're
An
asking here.
acceleration? Yeah, no, I'm asking that. What's the acceleration? What's catalyzing and engineering the acceleration?
Rockets?
Rockets. So you're saying, you just said something can't be flying, right? You said to be going 17,500 miles per hour, you can't have anything other than orbit that accounts for that because you're moving too fast. Then I ask you, how do you get from 17,000 miles per hour to 25,000 miles per hour? And your answer is rockets.
Okay, so
That's a contradiction.
okay, so I think I understand where you're getting confused here. So let me try to break this down. If you're having an object that's going 17,500 miles per hour, and let's say you need fuel to maintain that speed, how long is that fuel going to last?
The fuel, what? I don't know. I don't know how it's going to last.
Well, let's think about this logically here. We're talking about using fuel and having enough energy within that fuel to get up to 17,500 miles per hour.
Yeah.
And we know how big a single stick rocket is. It's pretty massive, but not infinite. And eventually it will run out of fuel, correct?
Sure.
Okay, so how is it that the International Space Station can then stay at its orbit for 20 years?
That's irrelevant to my question.
No, actually, it isn't, because what you're saying is that, or at least what I'm interpreting you saying, is that you don't believe that the terminology, or I should say the physics, makes sense because, well, rockets can get there and stay there. That shouldn't be any issue whatsoever. Actually, no, you need something, you need physics itself to help you with that, which is orbit. Orbit is the only reason.
Let's go back to your statement, and you could either double down on it or retract it.
I think a clarification is needed. Rockets get you to that speed.
Okay.
Orbits keep you at that speed.
Okay, great. So you're saying that nothing can be traveling at 17,500 miles per hour unless it's orbit, correct?
Constantly. Correct.
Constantly, okay.
Correct.
Now, the fact that you said rockets could get you from 17,500 miles per hour to 25,000 miles per hour, that means that you can have something else.
What else would there be?
The fact that you're appealing to rockets to increase your speed or even lower speed means that you can use fuel and engineering to manipulate speed. So even your first statement, like to get you to 17,500 miles per hour, you're saying now, well, something can't be moving that fast constantly without what we call orbit, correct?
Yeah, but the International Space Station, once it gets up to that speed, it's not constantly under rocket propulsion. And so something else is obviously at work here. So what do you believe else could be at work there if not orbits itself?
I don't know. I don't
I
know.
know it's orbits. That's how the International Space Station is doing what it does. When we looked at the International Space Station, when we looked at it, it wasn't under continuous rocket fire. You would have saw that. It would have made a light. But
Does it
when
need a boost?
every now and then, but
So
that's
then
not constant.
no, of course, dude, you just contradicted yourself again. The
I
fact
don't.
that it need,
If you want to assume that, that's fine. You're allowed to be wrong.
The fact that it needs a boost means it's not just orbit.
Yes, it is just orbit.
Does it need a boost?
Yes, it does need a boost.
And it's
but
not just orbit. That's
no,
called
it is
A
just
doesn't equal
orbit.
A, dude.
It is just orbit, sir. I will explain how you're wrong.
Does it need a boost?
Yes. Now, would
And
you
it's
like?
not just orbit.
Then would you like me to explain how you're wrong?
Explain how it's not a contradiction.
Okay, cool. So this is the part where we have our conversation. So when it's in orbit, it's able to stay up there without needing a Falcon 9 continuously pushing on it. Now, an atmosphere is moving against it while it is in orbit. It gradually, ever so slightly, slows it down. That doesn't change the fact that it's in orbit. It is a stable enough orbit for multiple orbits, multiple rounds, over and over and over again. There's a thing called a stable orbit, which is what we would see with, like, for example, geostationary satellites. You have partially unstable orbits, which is where the International Space Station's at. And then you have totally unstable orbits, like what happened with the Falcon 9 failure. There's more than one way to skin this cat. There's more than one way to describe these things. And what I think you're getting bogged down here is the terminology in which we describe these things. So if we were to look, you said engineering could describe things. Rockets don't have infinite fuel, my guy. They don't have infinite fuel. In order for the International Space Station to even be possible, then something else would have to do the work. And the other thing that does the work where they can actually maintain this orbit with only periodic reboosts, which are not to the scale of a full-scale Falcon 9, is because it has traveled at orbital velocity, it's at an altitude where orbits are a thing, and obviously it's traveling fast enough that the atmosphere isn't ripping it apart. And the third thing I was going to bring up is that when we looked at the International Space Station, you see these massive, absolutely massive solar panels off the side of this thing. It looks like a giant H. And these solar panels make this thing the most unaerodynamic craft ever. It looks... This is obviously something that wouldn't fly in atmosphere. And so...
Why is it aerodynamic? What is it aerodynamic for?
No, it's not aerodynamic. That's my point.
Oh, you said it's not aerodynamic.
It's not aerodynamic. It's the most unaerodynamic thing that you can possibly imagine. And so the mere fact that this unaerodynamic spacecraft with these very thin thin solar panels aren't just breaking off mean that it's in an environment where wings would be useless in generating lift.
So what you're saying is that your statement isn't that only orbit is necessary. Your statement is that what you call orbit, the constant falling forward, if you will, very far out, keeps motion, but you need a boost every once in a while. But you're also saying that the particular level of atmosphere, like some tiny molecules or whatever you would say is pressing against the ISS, you're saying that it definitely won't speed up, right? Is that what you're saying too? Like it won't speed up on its own if you just leave it?
Well, yes, it will speed up, but I don't know what you mean by...
Well,
could you repeat that question?
Sure, sorry, it was a little confusing. I was saying that imagining that something called orbit keeps something moving in a particular speed and altitude, so to speak. I'm asking, well, if you need a booster to keep the velocity up, do you need a booster to keep the velocity down too?
I'm going to try and answer that. I might be going off into the weeds here, but try to drag me back in if I can.
Okay.
But when we're talking about orbits, the orbit by itself is fine. However, there's something in addition to orbits that we also have to deal with, and that is the atmospheric drag that we're dealing with at that particular altitude. Now, the further out you go, the less of an issue the atmosphere becomes. So remember when I brought up geostationary satellites? Geostationary satellites are so far away from the Earth that the amount of drag that they could possibly experience from the atmosphere is so minuscule that those orbits will be stable for millions of years. The further down or the closer you get to Earth, the more drag you're going to experience. Now you may have an orbit that's stable for only tens of years, and then you go further down, you may have an orbit that's stable for only a few months or weeks or days, depending on your altitude. The orbit itself is fine, but we're also dealing with the atmosphere, and NASA and the controllers of the International Space Station, they account for this with periodic reboosts. They said, okay, we know that this orbit is going to be stable for most of the time, but there's going to be that 1% of the time that we're going to have to do a periodic reboost to keep it in low Earth orbit. Now, they want it in low Earth orbit because the area around the space station is relatively free of debris, because other objects that don't have the capability of doing periodic reboosts will eventually fall down to Earth, leaving the space around the International Space Station mostly free of hazards, and it's easier to get spacecrafts up there because it's closer down. So you need less delta V to actually get there, less fuel, less energy to actually get to the International Space Station. All of this is taken into account. And so when we're looking at the International Space Station, we say, okay, even on a bad day, even on an absolute bad day at its lowest altitude before a periodic reboost, this thing is going to be traveling really fucking fast. We're talking 4.7 miles every single second. Every single second. And then we ask ourselves, okay, can a plane go that fast within the atmosphere? No. Can a balloon ever hope to go that fast within the atmosphere? No. Both a plane and a balloon would rip itself to shreds. Okay, how does it look? Well, it looks like what an International Space Station will look like, with these huge-ass solar panels on each side. And these solar panels make it really shit in Earth's atmosphere. It would just rip itself apart again. I mean, it would be really, really shit in Earth's atmosphere. And so, okay, so it's traveling 17,500 miles an hour. It's 250 miles up, and it's, looking like a space station. Basically, we come to the conclusion where if it looks like a duck, quacks like a duck, acts like a duck, it's safe to say it's a duck.
Yeah, but the question was, does the space station need a booster to maintain a lower speed as opposed to just a higher speed?
If you're referring to deorbits, then yes. SpaceX was actually contracted to do a feasibility study or to start engineering the equipment needed to eventually deorbit the International Space Station and to do it safely. What they're going to do is that they're going to dock a Dragon spacecraft to the front of the station, and then they're going to use a series of modified Super Draco thrusters, I think, and they're going to fire in the opposite direction of travel. So it's traveling forward, they're going to fire backwards. That's going to slow down its velocity, which means that its orbit is also going to drop, and it's going to drop so much that it's going to re-enter the Earth's atmosphere and burn up.
Okay, without deorbiting as the goal, the question again is, we have an orbiting ISS, right, at 250 miles out at a certain speed, and you're saying eventually it loses speed, so it needs a boost. I'm asking you, does it ever gain speed and need a boost in the opposite direction?
No, it doesn't gain speed in terms of what would be a stable orbit. No, it doesn't ever gain speed. It only loses speed at that particular altitude. There are certain altitudes that you could theoretically get to where there's no change in velocity whatsoever. That's not the case because of the atmospheric drag.
Okay, but if it was higher, it would gain speed?
No, if it was higher, it wouldn't lose or gain. It would just maintain.
It would maintain. So, okay, so there isn't a phenomenon where if you're breaking free fully without an added force or release of mass, let's say, into a vacuum, you wouldn't increase speed ever.
You got to think of it like this. Orbits are essentially free fall. I guess I should have asked this first.
That's what I was. Yeah.
Do you know how orbits actually work?
Well, I just correct me if I'm wrong. Is a combination of falling constantly paired with velocity moving forward, and it's basically an illusion, but it's actually falling. It's just falling in a direction that's constant around an object.
Yes. So basically, think of it like this: if I have a ball and I throw it sideways, it's going to curve and hit the ground. If I take that same ball and throw it harder, it's going to curve and hit the ground, but slightly further away. All of a sudden, I turn into Superman, and I can chuck that thing really hard. So what if I chuck it so hard that the curve of its arc matches the curve of the Earth? The ball would always be curving towards Earth, but Earth would always be curving away just as fast. And the end result is that it would keep going around and around and around. Now, you could slow the ball down, which would, make its arc shorter, thus impacting the Earth if you had something to slow it down, like, for example, the atmosphere. So what if we threw that same ball in an environment where we didn't have to deal with that pesky atmospheric drag nonsense? Well, then it would just stay around and around and around. What rockets are doing is that they're simply, and for lack of a better term, throwing their objects around the planet so that they can go around and around and around over and over and over again. And so if you slow down your velocity, if you slow it down, then your orbit becomes unstable because the path of your arc intersects the surface of the Earth, and that's not good. You want to go fast enough so that the path of your arc goes around the planet.
Okay, so based on that, would you say it's a misnomer to say there's such that zero gravity? That's just a term for the absence of
it's not called zero gravity. It's called zero G. But I can see where the confusion is at. It's commonly referred to as microgravity, and I don't like that term either. But essentially, they are in a state of perpetual free fall. That's why astronauts are floating. They actually experience. I did the math on this one time, so I'm just gonna try to remember the number. I think they experience 88% of the gravity that we experience down here on Earth. The reason why they're floating is because they're always in a state of free fall. But I believe that at that particular altitude, it is about 88% the amount of gravity that we feel here on the surface.
Gotcha. So it's just constant falling. So why is it 250 miles up, not 200 or not 300?
It can be any one of those altitudes. So, for example, and to my Chinese viewers, I am going to mispronounce this. Please don't at me. I already acknowledge that my Chinese is quite shit. But I think it's called the Tiangong space station. It's the Chinese space station. Tiangong, I believe it's pronounced. I could be totally wrong on the pronunciation, and if so, I do apologize to all 2 Chinese viewers. But Tiangong is actually at a lower altitude than the International Space Station, if memory serves correct. Or it could be slightly higher, but essentially any one of those altitudes is fair game so long as you can do so stably, so that you're not dealing with the constant buffeting of the upper atmosphere. So if you wanted to put a space station at, let's say, 500 miles instead of 250, you could totally do that.
I have a question. What is the minimal altitude to reach that's objectively established where you would just perpetually fall forward?
I don't know the exact answer to that because it all depends on the atmosphere. I do know that the Kármán line is the point at which the lift from your wings wouldn't generate enough lift for you to not achieve orbital velocity in order for you to maintain that altitude. I know that much, but that is very much an unstable altitude to be at.
I have another question. If you go way up, like 250 or higher, and you just go straight up, straight out, and you don't curve the line and basically move forward in velocity, what happens to an object that you just bring up into space directly vertically without doing the curve sort of deployment of the object into a sort of orbital motion forward? What happens if you just bring an object up, let it out of the cage, but you're not moving in any other direction? You just let it out. What happens to that object?
You get what's called a suborbital launch. Suborbital launch is actually something that Jeff Bezos does as well. Remember Blue Origin I mentioned previously? They have another rocket called New Shepard, and despite looking most like a penis, it is a suborbital launch where paying customers pay $100,000 per seat. You may have seen a video from Dude Perfect, I believe. Dude Perfect actually took a ride on New Shepard, and New Shepard, they went straight up and went straight back down. And I'm serious, guys. Look this shit up. Look up New Shepard on Google. Try not to laugh. I'm dead serious. Do it right now, and you'll see what I'm talking about. But they launch straight up. And so when they launch straight up, they will experience about 6 minutes of weightlessness. But the reason why the reason why they experience that weightlessness is because once the acceleration stops, they're just following a parabolic arc that just takes them right back down again.
I understand.
The parabolic arc is just so sharp that it just comes straight back down.
Yeah. Let me ask you a different question. Is there an altitude at which you can deliver an object without moving it in any direction that mimics the spherical shape, right? That you just bring it up. Is there any altitude where you can release an object and it simply just stays exactly where it is relative to the surface?
No. Eventually, if you go high enough, then what would happen is that you would eventually get outside of the Earth's sphere of influence, where you wouldn't immediately be taken up by other gravitational influences, like, for example, the sun. Now, where that point is, I'm not exactly sure, but I'll even tell you this, that there is a spot called Lagrangian points, and this is kind of a mind fuck, so bear with me for a second. Lagrangian points are balance points in space, right in between the balancing between the Earth and the Sun. And there's one in front of us and there's one in back of us. So, but for simplicity, let's go with Lagrangian 1, which is between the Earth and the Sun. That spot is 1 million miles away from Earth. So at the very least, the Earth's sphere of gravitational influence, at the very least, reaches out to where the Lagrangian points are, which is, again, 1 million miles from Earth. So in order to be outside of the Earth's sphere of influence, you would have to, I would think, at least go that far out before you are sure to never come back.
I guess the question is, let me just get this clear. That point you're saying, if I asked you at what point up away from Earth will an object no longer just fall down? Is that what you're saying is the point, or that's not identical? That's not the same thing?
It would not fall down in the sense that it would just, at that point, be in its own orbit around the sun.
I know, but is that referring to the same point? So if I ask, is there a point at which you can release an object out away from the Earth where it just stayed where it was, it just floated? Are you saying that Lagrangian point is that point, or that's a different thing?
I would say it would be you would have to at least go that far to have any hope of that happening.
Okay, so if that was the case, it was so far out, that wouldn't be, because what I was trying to lead to as an inquiry is, like, would it be ideal if satellites were just stationary and didn't move the way you're describing them so quickly?
Not at their altitudes. No, if you went to the altitudes of where satellites actually are, so, like, let's say between low Earth altitude and geostationary, if you stopped them in place, like if you somehow waved your magic wand and were able to just make them stop, cancel all velocity relative to the Earth, they would immediately fall right back down.
I got you. That's what I'm asking. Is there any altitude that is more local where we can see the effect where you're just not bound, but you could just have an object in space, and then from that view you wouldn't need a booster, you wouldn't need anything, you would just need an object in space?
Not in that way, no.
Okay. The other thing I had a question about is just deploying getting things into orbit, because we talked about deorbit. If we can go on to getting them to orbit is another thing that I have questions about.
Okay.
So what you call a payload, whatever's inside of the rocket, you strap it to a rocket, it goes very far up, and that there's this point, I guess, you said could be 150 miles up, could be somewhere, there's some gradient, I assume.
Yeah, I would say that if you want your satellite to have any sort of a lifespan that's worth a damn, it would be
Away
prudent to go beyond 300 miles
because of the mass, avoiding
because
the
of
mass.
the atmosphere.
Yeah. Okay. So let's say we do that. The process of that, you're taking what we know as ordinary propulsion against air, the way planes work. It's pushing against mass that's thicker, denser, closer to the surface. And then you get up to a certain amount. I don't know what the threshold is where you no longer have the capability. It's weakened to be able to push against mass, right? I wanted to ask, what is that threshold in miles?
I don't understand that question you asked. Are you saying that there's a point at which rocket propulsion becomes non-existent in space?
Well, the kind of rocket propulsion we need locally is the kind that pushes against air mass.
Well, rockets don't push against air.
No, in space you're saying they don't, but to get them out of the atmosphere, they're pushing against air, right?
Well, they're punching through the air, if that's what you're saying.
But they're pushing against, the thing that gives them the punch is the propulsion out the back against air, right?
No, not against air. It's just the mass being fired out the ass end.
Wait a second. So you're saying when someone launches a rocket from ground level, that's pushing not against air?
It pushes air out the way, but as far as what provides the thrust, it's simply the act of taking the mass that is within your tank and firing out the ass end at Mach 5. So the best way I can describe this is that if you're sitting on a skateboard, and let's say you
throw
have
a bowling ball.
the bowling ball and stuff like that. When you shove the bowling ball away from you, you are actually going to be pushed back. Now, there's a few things that happened at that particular moment. The first thing that happened was that you lost mass in that process because it started out as you and the bowling ball, and now what's left is you and not the bowling ball. So you ended up losing mass in that you traded mass for a force. Mass times acceleration equals your force. So you lost that mass and you translated that mass into a force. Rockets are doing the exact same thing, but instead of bowling balls, it's literally the fuel within their tank. And so the next thing that you need to do is that you need to be able to fire that out as quickly as possible. So the second thing you did was you shoved that mass really, really, really hard. Well, we're going to use something else to shove that mass. Instead of using our muscles, we are going to use a chemical reaction. And that chemical reaction releases a metric fuck ton of energy. It's loud, it's brutal, and if you've never been to a rocket launch, I highly recommend it. It is an amazing experience. But that energy, that release of energy, fires the mass out the ass end really, really, really fast. Because remember, force is mass times acceleration. So if you increase the acceleration, you're going to increase the force that is applied to the rocket. You're going to increase the amount of force that is produced. That act alone happens regardless of the medium that you're in. So it doesn't matter if you're dealing with 1 bar of atmospheric pressure, half a bar of atmospheric pressure, a quarter bar of atmospheric pressure. It doesn't matter because that reaction, that equal and opposite reaction still happens regardless of the environment that you are in.
So when you're operating a boat, are you also saying that because you said no matter the medium, are you saying that a boat isn't pushing against water?
A boat is pushing against water, but a boat isn't losing mass when it's doing so. A boat is pushing against a medium, the medium being water. A plane is pushing against air, being its medium. A rocket doesn't need a medium to work because a rocket is simply using its own mass as a reaction mass, whereas a boat is using the water that's around it as the reaction mass.
Okay, I'm just saying, like you said, regardless of the medium, it seemed to be the case that if it was regardless of the medium, you could have a boat that didn't use a propeller that we know of. It just it just releases gas under the water, and it would work as a boat just as well as using a propeller.
As if we're talking specifically about rockets. Specifically about rockets. Then
Oh,
it
okay,
doesn't
only
matter
rockets.
what medium that you're using. If you're talking about a boat and you're talking about a plane, those are entirely different things. It's like comparing regular 2% milk to almond milk, which is not milk, regardless what any vegan says.
Okay, so is that you're saying that applies to an airplane too?
No, it doesn't.
Horizontal.
It doesn't. What I said was is that a boat and a plane are totally different concepts to rockets.
No,
Rockets,
plane and a rocket. No, I'm comparing a plane and a rocket. A horizontal plane that's going to take off, is that pushing against air to get into the medium air?
into the medium, there's just air in that case, but yes, it is pushing against air. Correct.
Yeah, I meant medium as in it now has mass to fin against to you know, change its attitude and its direction using
Yes, it
fins, right?
operates by sucking in air in the front, shoving it out the back. It also reacts by flaps and control surfaces on the plane, correct? Rockets don't use that principle. They use the principle of every action has an equal and opposite reaction. And so they have their own mass that they're going to be expelling. Once you expel all that mass, then it's done. The rocket has been expended in that case. And so the only way that they're going to go to space, given the fact that there is no air to push off of in space, is to utilize that purpose. Otherwise, we would just be using jet engines to get to space.
No, I know. I'm. That's what I was trying to make the distinction. I'm not sure how you could say an aeroplane is pushing against air by pushing out a force, but you're saying that a rocket, right at ground level, when it's sitting vertical and launches, that's not pressing against the ground and then the air. You're saying that there's no it's not pushing against the mass of the air at all.
If you have a basketball and you absolutely pelt that basketball against the ground, but your hands let go of the basketball before it pelt the ground, did you push against the ground or did you push against the basketball?
The ball.
The ball, exactly. So let's make that ball smaller. Let's make it marbles. I throw a fistful of marbles at the ground, but I let go of the marbles before it hit the ground. Did I push against the ground or did I push against the marbles?
I'm sorry, I missed that. The second one.
Okay, just to repeat. Let's say I had a fistful of marbles. I pelt the marbles at the ground, but I let go of the marbles before it hit the ground. Did I push against the marbles or did I push against the ground?
Marbles.
Marbles. Okay, let's make it even smarter. Two molecules of gases that I fired out the backside of a rocket engine. Did I push against the molecules of gases at Mach 5 or did I push against the ground?
Say that one again.
Okay. So the same way with the ball, the same way with the marbles, we're just shrinking the spheres, I guess. And now we're at the point of individual atoms or molecules. Did I push against the molecules or did I push against the ground?
At the launch, the actual launch, I guess you're pushing against the molecules.
The molecules, exactly. The ground is irrelevant to this equation. So what a rocket engine will do is that, yes, it will push the air out of the way, but the air itself is not providing the thrust. What is providing the thrust, was providing the force, is the chemical reaction within the rocket engine itself. And that chemical reaction is only happening because of the fuel that it itself is carrying. It's not taking any medium from the outside to replenish itself like you would with a boat propeller. It's taking everything around it and using that to move itself forward. Rockets don't do that. They have no intake. There is no vent to suck in air to make that reaction happen. It is entirely dependent on its own mass and what it itself creates.
Okay, so what you're saying is a rocket taking off is slightly different than a plane taking off.
Yes.
That plane is pushing against air. When it's stationary, it's pushing against air. It's wanting to move forward against the air mass behind it and wants to cut through the air mass in front of it. And you're saying when a rocket takes off, none of those variables are really in play. You're saying the massive explosion, the fire releasing from the rocket itself, the structure, is just the act of letting go of the mass. You're saying is propelling it up into the air.
Yeah, well, firing it out, but yeah, same thing. Basically, It uses its own mass as reaction mass, and its own mass, i.e., the fuel that it's carrying, which is liquid oxygen, RP1 kerosene, that kind of thing. There's a chemical explosion happening, but it's a continuous explosion. That's what a rocket engine is, essentially. It is a controlled, continuous explosion, which releases a shit ton of energy, and that is what does the work.
It has to be a shit ton of energy because of the air mass, right? But it's less energy needed as you go up. Is that what you're saying?
Not necessarily. No, the reason why you need a shit ton of energy is because you need to accelerate your mass to the appropriate velocity. So even if you were in a perfect vacuum, it's still going to require energy to accelerate an object, any object with mass. So if I wanted to continuously accelerate that object and continue to accelerate all the way up to 17,500 miles an hour, you know, even if you're in a vacuum, that's going to take a lot of energy. And so if you want to do that work, you're going to need a lot of energy.
Okay, cool. So then let's go back to the LEM, 1969 taking off from the moon. It's leaving behind the bottom section of the module, which holds about 4 to 6 tanks of combined things, oxidizer, water, fuel. And then the smaller object has a fuel, what is it, aerosine or something like that, has water, has a scent engine, has helium, has an oxidizer. If you say that it requires a shit ton of energy, this is what I'm confused about, and maybe you could elucidate on this. Is that the little the little top part of the lunar module that took off? When you look at it, I have it on screen on my end. It has a couple of little nozzles for what they call the mass, where the mass would come out to the immense energy that you needed would come out to not only push the object forward in some sort of trajectory, but also arrange the attitude of the object as well. And I'm just wondering, like, from your view, is it still hold true that this little piece of the LEM that's leaving from the moon would also need a massive amount of energy to not only increase its speed to about 5,000 miles per hour to meet up with the central command, but it would also need a massive amount of energy to self-correct or correct, let's say, its attitude orientation to the central command. Is that correct?
Yeah, let me just, I will answer that question, but first let me say I do want to eventually get back to us acknowledging that the International Space Station is a thing. I think we kind of went into left field here, but as far as the small thrusters that you're talking about, those are known as reaction control thrusters. And those, I believe, are, again, I'm not an expert on this, so audience, correct me if I'm wrong, but I believe they use cold gas thrusters, just pure compressed gas. And their only job is not to accelerate or to cause any sort of dramatic shift in orbit. Their only job, and the reason why they're so small, is to literally point the damn thing. So if I wanted to just point or increase my angle of attack in a certain direction, all I would have to do is just a little bit of puffs here and there.
I got you. Yeah.
And that would be enough to get me pointed in the right direction.
I understand the principle, but I guess what I was looking at, the reason I asked is I was looking at this, and earlier I was looking at what Neil Armstrong was training on, and he was training on a little, like, it was basically a machine like that had a jet under it that pointed down at the ground that got it into the air. But he said this is the thing he's practicing doing a maneuver. But in this case, you're using a jet beneath you that's keeping you elevated, and then you're using sort of a tilt maneuvering method to change direction.
Gimbaling,
kind of like a helicopter look, where you tilt down and it kind of goes forward.
Well, that action was gimbaling.
Gimbaling. Okay, that's good word for it. So with this though, that's what I was confused is how that was adequate practice, given that in this machine you actually have to practice using these tiny nozzles, perfecting a combination of directions. In this image that I have up on my screen, there's 2 sets of visible nozzles on either side of the circular sort of pod, and the little section has one outward, upward, downward, right, and I guess there would be one left. Basically, every axis of a, basic geometric axes. So there's two, but if Neil Armstrong was practicing, but he didn't practice on using the nozzles, I'm just wondering how that would be adequate practice using the giant floating machine locally.
So
Like
long as
they showed it, but I was like, well, that's not practice for the same type of machine. It's like you're saying, can we practice on one machine that is completely different in the way in which it operates and its maneuvering, to practice for something that's not that? I just wonder, like, why, how is that adequate?
well, it depends on one's opinion as what is adequate. I would say that you can only get as good as you can get here on Earth. There is no such thing as getting absolutely perfect training for something that was never done before. At that particular moment in time, man had never landed on the moon before. They didn't know how hard it would be. They could only do the best that they got. So they did some math and they said, okay, we believe that this geometry with this amount of thrust and this type of layout of this particular machine would be the best simulator in that type of situation. And so we're going to go ahead and utilize this type of simulator, not because it's going to be a one-to-one direct example of what's actually going to happen, but we're going to get you skilled enough so that when the real thing does happen, you're not going to immediately kill yourself.
Skilled in what, though? That's like saying, like, if I practice enough golf, I'll do fine in the football game. To me, it's disanalogous. It's not like it's not even close to a one-to-one. The same criticism I have of, like, underwater training. I can see why visibly training underwater for a spacewalk would look like a spacewalk, but I don't get that training people who are preparing for a really dangerous scenario where there's zero resistance in where they are. That means that even pushing off of a ledge slightly, if you hadn't practiced or known what that felt like, could send you into massive velocity into the vacuum of space. Then you're practicing underwater.
I would use a different example. I would say that it's similar to practicing on Top Golf, and that it can get you moderately better at real golf. Yes, they're two different sports, but they are similar enough, and that's what they were going for. They knew going into the Apollo program that some things were going to be novel, and there was absolutely nothing they could do to make it absolutely similar. So when astronauts train, like, for example, in the neutral buoyancy lab, which is that big giant pool, the reason why they're using the neutral buoyancy lab, the reason why they're using water is because that's literally the best they can do, because we haven't yet invented the technology to at will turn off gravity. We can't do that. And so we can only do the best that we can. And I would say that machine was very much analogous to what they were going. Oh, absolutely.
Do you think?
Absolutely. The controls were exactly the same. The gimbaling geometry was exactly the same. And at the very end of the day, that type of geometry, that type of apparatus is what they would have had to use in order to get to the moon. It would be different if he said, "Hey, listen, in order to land on the moon, we're going to make you practice on this unicycle."
Wait, no. I think you're misinterpreting what I'm bringing up. We're not talking about. Okay, so yeah, you're saying getting away from the central command to get and land on the moon. You're saying, this thing, I'm going to bring it up for my own audience here. This machine, you're saying, is an adequate training mechanism. That's what you're saying, right? It's adequate for preparing for the real thing. That's what you're saying.
It's as adequate as it could have possibly have been.
Right, but that like, let's say something's completely inadequate, you can still say it's the most adequate it could possibly be, right? It doesn't say it's adequate.
But that's the thing. As adequate as it can possibly be is the best that you can do. And also, people knew that no matter the training, no matter how good the training material that these astronauts got, they knew it was a risk. They knew it was a risk, and that there was a very real possibility that they were getting into something that they were completely unprepared for. But the reason why they chose these particular individuals to do this particular mission is because they have been placed in very sketchy situations before. They were trained pilots that flew experimental aircrafts. And so they wanted people that would be cool under that kind of pressure, and that's exactly who they got. So they found people with nerves of steel, courage, titanium balls, essentially,
Grit.
and they did
American
the best
grit.
job they possibly could with what they had available to them.
Would you say grit?
Grit would be a good way of describing. I don't like the word grit; just sounds like sandpaper. But yes, grit could be a nice thing or a adequate thing, an adequate word.
Okay, but what? Let's go to the water thing then too. Do you think training underwater, how does that prepare you for on like a situation you can't fathom where pushing off of something will send you into some sort of direction without being stopped, right? I'm wondering how it is you'll say water is a good preparation for the complete absence of matter and mass.
Well, I don't think it's trying to mimic that in particular. I think what they're doing in the neutral buoyancy laboratory is that they're practicing what they're going to have to do on the outside the station. Each mission to the station has certain objectives that they have to complete, and they train for these particular objectives. The best way to train for these objectives is to actually do it a few times in a controlled environment so that when the real thing happens, you're very much prepared. So they have simulators underwater, and they are positioned on these apparatuses in the exact same way that they would be up there in space. And so to mimic the actual experience, your orientation is shifting constantly, for example. That orientation shift and the way that you're going to be moving all of your tools, for example, that is best mimicked underwater at the neutral buoyancy laboratory. Now, to say that it's a perfect one-to-one would be a bit of a stretch, I would say, but it's the best that they got. And
I think I'll just push back on this. Don't you think that a harness, like being suspended in a harness, absent being able to go upward, like moving upward easily, a harness, wouldn't that be a better example, like a harness up in the air?
It might be in a few applications. It could be. I don't know.
Yeah. Someone asked a question, if you don't mind. He says, how does the ball throwing analogy apply to geostationary satellites? Throwing analogy.
So, like, how does it... Okay, so if you have a ball and you throw it sideways, it's going to curve and hit the ground. So that's how you first get into orbit. That was just to describe what an orbit actually is. So a little bit of orbital mechanics here. The further you go away from the Earth, the less of a gravitational pull that you're going to have to deal with, which means the less velocity you're going to need sideways in order to maintain that orbit. And so there is a certain altitude where you are the perfect distance away that your orbital velocity will take you around your complete orbit at the same rate that the Earth rotates. And so from Earth's perspective, looking up at that satellite, it would appear to remain in the exact same part of the sky. That's how you get like Sirius XM satellite radio, for example. It's at that same part of the sky because it's at a certain altitude where its orbital velocity and its orbital period is the same as the rotation period of the Earth.
Okay, another person asks similar question, a different scenario. The basketball marble example, he says, leaves out that our muscles acting as a force, and then the fact that you don't gain lift from pushing against them, you're just going to say, well, no, it's at some point you're going to say that you could release something from your body, so to speak, then you're saying you would have lift. So is that essentially what it would be? Is that
I did bring up muscles previously to that guy. I said instead of using our muscles, if you remember what I said earlier, I said instead of using our muscles, we're using a chemical reaction to do the throwing. And I can tell you one thing. If I had the capability to throw a medicine ball at Mach 5 towards the ground, oh boy, my ass would be soaring into the sky. I'll tell you that much right now. But unfortunately, I'm not Superman. I don't have the capability of throwing a basketball or a medicine ball at Mach 5 towards the ground.
Hmm.
But I know something that can throw mass at Mach 5 towards the ground: rockets, because they have a chemical reaction that's doing the work.
So, by on that principle, is it possible to have really tiny chemical reactions that aren't so crazy and explosive to keep something like levitated, so to speak? I mean, this is more hypothetical.
I don't know of any such reactions. If you know of any, please inform me.
Well, no, I don't. I'm just wondering what the future engineering would be if it's the case that a mere chemical reaction, not a mere one, a big one, that's moving mass away from something, if that was somehow
The what you
turned to
would
a
do,
smaller thing than it
you
with the
can
same power.
levitate. You can levitate rockets. You would just decrease the size of the nozzle, or yeah, you would just use a smaller rocket engine essentially.
Mm,
And then that smaller rocket engine could be sized just so that the upward force matches the downward acceleration of gravity.
gotcha. And then another thing that I thought of was thinking just visually, like the lemon in the vacuum of space. Maneuvering, you said it's using one thing for a thruster, which produces its direction, and you said the other thrusters are more for orientation, which is attitude, correctly, like the way in which you're facing.
The
Is
way
that
in which
correct?
you're facing.
Okay, I guess my question is like, from that view, then, are there more thrusters required then? Because attitude, like for instance, you can be sent into a direction and facing the wrong way, and you could hit side thrusters to change the way in which you're facing, but not the direction. So are you saying that back to the lem that the like turning, for instance, like you're saying the side thrusters wouldn't be used for turning, but they're used for facing directions, right?
Well, turning and facing directions are synonymous in this context, and also
They
you can
are.
use, yeah,
Wait. Can we let's just stay on that for a second. If you're in space and you're sent in one sort of line of direction, you could be facing a different way, right? Like facing forward and still going in the line of direction. And if you put remove some mass from your pod, right? It could change the tilt of the machine, but not change the actual direction, right? But then
yes.
you're saying there's some threshold at which the tilt is no longer the thing. Using the same thrusters, the tilt thrusters. That's kind of what I'm asking. To turn, are you using the same thrusters as to tilt? If turning isn't actually synonymous with tilting.
Okay. Well, we said that that pointing was synonymous with turning, not tilting. So tilting is a different word being used. But essentially, you can use those thrusters for two things: minor corrections. So, like, let's say if I'm hovering right next to the International Space Station and I want to bring it into docking, I would use those small maneuvering thrusters, the RCS. I can use those to orientate myself, to point myself in a particular direction, or move myself in relation to the International Space Station at really, really slow speeds. But I would use my main engine when I really need to get up to speed, i.e., lifting off from the moon and so on.
Speed, yeah, the speed. And
You would
what
want the
speed?
bigger engine to do the big work. You would use the smaller engines to do the smaller work. And the smaller work being done would be like turning yourself in a particular direction, or making so that you point in a particular direction, or doing very, very small, minute changes to your
Yeah.
direction.
What velocity what speed would you think was necessary to lift off from the moon?
Maybe a mile a second.
A
Maybe.
mile a second?
Maybe. I could be wrong there, but I think it is either less than a mile per second or about a mile per second, but
A mile per second from the ground?
from the in relation to the surface of the moon.
Okay, so you're saying to take off from the moon, you'd want to reach a mile in 1 second from the surface of the moon, and that would have to increase, right, in speed eventually to kind of meet up with the central command, correct?
You would launch at a particular point where you intersect the command module at the very moment that you hit your orbital velocity, and
Okay, so
that can easily be
gotcha.
calculated.
Okay, that makes sense. But you're saying a mile from takeoff, you want to be starting pretty fast, about a mile per second, right?
No, from takeoff you're at zero when
No,
you when you take off, then you would gradually increase relative to the surface of the moon to a mile per second.
Oh, okay. So eventually you get a mile per second. But the takeoff itself, you can do super slow or relatively slow, or it doesn't matter.
Your acceleration is ultimately irrelevant. It's whether or not you can get to that particular velocity before your fuel runs out.
Oh, right. So because you got to catch up and connect to the main
So long as
location thing,
you
right?
meet them at that particular point in space at the velocity necessary, your acceleration is ultimately irrelevant.
Okay.
So whether you want to accelerate at 2 Gs, 5 Gs, 10 Gs, dear God, it doesn't matter so long as you can get to that particular point in space at the
Mhm.
velocities necessary before your fuel runs out.
Gotcha. I understand.
Now,
Uh,
if I can kind of
sure.
just shoehorn it back to the International Space Station because we went on the side tangent for a bit,
Okay.
I wanted to bring up the evidence that I had one more time, and I just want you
Sure.
to tell me why it may not be enough, or even if it is enough.
Yeah.
So we basically spoke at length about orbital mechanics, velocity, how rockets work, the atmosphere, and what effect it actually has on spacecrafts and stuff like that. Um, and I'm going to be confident at this point in saying that you know enough that you know that the International Space Station cannot be an aircraft in the traditional sense. It's not. It's very unaerodynamic. It doesn't have the ability to produce its lift from a surrounding atmosphere. That the only way it can stay where it is to be in orbit, and yes, occasional reboosts necessary. But that is still the definition of a successful functioning satellite. Just because it has people in it, who cares? It's still a satellite. So if I was able to prove to you that it
Hmm.
is going that fast, it is at that altitude, it is that particular shape, it even looks like a station,
Yeah.
would that still not be enough for you to be confident in saying, yes, the International Space Station, one, is in space and therefore is a satellite?
I would say I would be confident enough saying that that's not an airplane or anything else I know as far as things that travel through air or anything above air. To my knowledge of what things do in the air, it doesn't fit the description, so I would grant that. As far as what it is and how it is, not necessarily. I wouldn't like concede. I would maybe say, oh, well, that explanation. Um, I don't see anything completely wrong with it necessarily, being the explanation.
So it is your position that of the explanations that are currently up for scrutiny, this one is the most acceptable.
Acceptable, yeah. Well, I'd say it's the most accepted.
The most accepted. Okay,
Yeah. Mhm.
that's I guess what I meant to say about
Well,
words.
I mean, acceptable and accepted, we wouldn't make them synonymous, right? Because there are previous models or notions of things that were accepted, and from your view, you wouldn't say just because they're accepted that they're acceptable. I would say they're accepted, um, that it's accepted. It's just that when it comes down to it, um, when you say something's moving through space and you explain how it's moving through space, that's a descriptive claim and it could be consistent or inconsistent. So I would give you that your description of the ISS and its movement is consistent so far as I know. Is that fair?
Well, yeah, it is consistent, and I don't want to get bogged down into the terminology, but I did want to challenge you on one thing. And that was, it's like, yes, it doesn't match any other thing other than a satellite. So if we are at the point where this is like the best possible explanation for what we're seeing and measuring, observing, and what anyone can do, we can even calculate it using orbital mechanics, and what do you know? It's right there, just as predicted. I must ask, what is still giving you pause on making that final step?
The final step of saying, yes, that's an ISS that was built
That
traveling
is a
it.
satellite, essentially. So what is giving you that final pause and saying that that is indeed a satellite?
Well, because the thing that you're claiming it is, you're saying, well, everything about that thing reads satellite, but that brings me into question what a satellite is. So it would be circular to argue that way. So I
Well,
mean,
we already went over what the
I would say,
characteristics of a satellite are.
yeah, I would say the thing that you're saying is moving very quickly in space matches your description of what a satellite is.
Yeah, so it would be safe to call it a satellite, but I want to know
No,
why you
not
wouldn't.
necessarily. Not necessarily. Like if someone is dressed like a woman, I wouldn't just say that they're a woman because they're dressed like it.
Yeah, but if I tear off their panties and there's a vagina there, where would we call it then?
Yeah, if I saw a vagina, I'd be like, that's a woman.
And I see orbital velocity up there, so what are we calling it?
An object moving in space.
So it's not a woman; it's just a person with a vagina.
Well, I mean, to say objects moving in space are all satellites, right? That's not a good reasoning. Like if you say there's something else that's moving exactly like a satellite does, but it's not a satellite, it doesn't follow.
It's not just an object in space. It's an
So
object in space that is behaving in the exact way that satellites would behave in. And so if we looked at, for example, if we were to calculate where the International Space Station is going to be at a particular point in time, and we're making those calculations based off of orbital mechanics, and it matches perfectly, then we know that that particular craft is obeying orbital mechanics. And if
Yeah,
it's at an altitude, that would make that possible.
I already granted that your claim of what something is consistent with your description of what it is and how it operates.
Okay.
I mean, that's
So
all.
so being that we have this, really really good consistency, for some reason that's still not good enough.
Well, because if you accept what the ISS is, right? There's a jump for me. That's why. If you're asking what's the leap here, that's gives you the reservation that you're hearing in my position, is that, and this is probably a different stream altogether, is that the assumption of that being a thing that was built by men, and it was built in the condition it's actually moving right now. I just don't have the evidence that that happened.
You mean, so basically your major roadblock here is videos of
Engineering.
its construction?
Yeah, like documentation of its construction, and I looked into the construction. And again, it's another first-time thing, right? You got to get it exactly the first time, where several different engineering firms from several different nations worked together, never having built this thing, and it was assembled first time, first shot, going 17,500 miles per hour, and I just don't see supportive evidence that's convincing to me as far as that was how that happened, I guess.
Are you
But
are you on the under the assumption that this thing was built in space, or was it assembled in space?
the claim is that is assembled
Assembled, yes.
at that speed, right? At
Okay,
that
so if
yeah.
we have images of the International Space Station literally changing shape as more modules are added, would that not satisfy that criteria?
What you're saying, you have images?
Oh yeah, absolutely. Remember my good friend
No.
Astronomy Live? He has a over 5 hour video documenting his own observations of the International Space Station. He's been doing this for a
How do you-
really long time.
What do you
And
mean he directly observed it?
directly, as in through his telescope, he was able to see the International Space Station through many phases of its
Did
assembly.
he happen? Did he happen to see a spaceship drive up and drop off the new part?
The space shuttle was indeed docked to the station at that time, and when the space shuttle leaves, you then see new parts added, because it's actually the space shuttle
I would look
that
at that.
brought all this stuff over to where the space station is so that it could be assembled.
Yeah, you can send me that. I'd be interested in seeing that.
Epic. Okay, so let's continue the rest of this conversation on a hypothetical, because I know you haven't watched it yet, and I don't expect us to be able to watch 5 hours worth of content on this live stream. That's a bit absurd. But let's go ahead and assume that you did watch it, and you see images through Astronomy Life's telescope, his LX200, and you see literally the modules being added, the shape changing of the International Space Station, the shuttle being docked to it, delivering the payload, and so on and so forth. You saw all of that. Would that then give you enough of a kick to make that leap to say, yes, this is a satellite?
Yeah, depending on how that footage is strung together and such, I would still use a skeptical lens to do it, but certainly it would push me in the direction. Yeah.
Well, it would be. I know how it's structured. It's structured according to their date, oldest to newest. It's following the line of progression as it actually happened.
So what you're saying is your friend through his telescope took photos and videos, videos being
Primarily videos.
but still, you have to basically stop it, right, to see the clarity of the image, right?
No,
So it's
not
like
necessarily. No, there are.
okay.
Now, don't get me wrong. It's yes, you're looking through a telescope. It does jump around a little, but if you want to freeze frame it, that's totally. That's
But
totally.
it's blur. I mean, I've seen videos. It's just I'm saying it's like it's so fast that it's a blur little thing where you can't make out like hard lines and shapes, right? From a video, you have to stop it at some point, right?
You can freeze frame it if you want, but Astronomy Live is very good at this sort of thing. What I'm going to do for my audience, and you can share with your audience if you so choose, I'm going to screen share something for you.
Sure.
All right, here we go. Screen sharing now. This is one such image from Astronomy Live that I tweeted out recently. I did this to push it onto a Twitter space.
Hold on a second. I gotta bring your visual back up just for a second. Sorry. Where are you? Sorry, my OBS is stacked with so much stuff here. It's a Discord meeting. Okay, here we go. Okay. All right. I think. Let me see. Where is it? Where are you? Something's in the way. What's in the way? Discord's in the way. Okay, there you go. Sorry about that. Go ahead.
Okay, so what you're seeing here is the International Space Station through his telescope. And so you can make out each individual solar panel. You can make out the SpaceX Dragon that's on the front of the thing. This is what you can expect to see from Astronomy Live, because Astronomy Live does great work with his telescope. Absolutely fantastic work. This is what we're seeing. This is the kind of thing that we were able to capture, but we were able to capture this same object as it progressed through its assembly. So the modules were assembled down here on Earth. They were then loaded into the payload bay of the NASA space shuttle. The space shuttle went up to meet the International Space Station in orbit, and then that's where the pieces were then assembled, kind of like Legos.
How much smaller is the shuttle that's carrying the payload in comparison to what the image we're looking at here is?
I don't understand the question.
What's the relative size of the ship that's meeting up with this thing and docking to it? What's the relative size to it?
Let's find out. Actually, we can do this quite easily. So let me type this in.
Because even if it was like 1/4 the size, based on that image, if he got that much clarity, what would be convincing to me is a step-by-step, because the docking you would assume takes it's not immediate, right? So the process, correct me if I'm wrong, would be that a space shuttle would make its way and meet the same movement conditions and alignment as the space station, right? And eventually lock itself onto it.
There you go. This image should give you a sense of scale.
I understand. Yeah, no, that's big enough to basically obtain the thing that I would want to see, which is that space shuttle right there getting closer and closer, being tracked closer and closer and closer to the ISS and attaching itself.
Being docked is as close as you can get, and we have
images. I have a question though. My question is, if the space shuttle itself has to very gradually get close to the thing, that would assume that there's two noticeable objects through a telescope that have to be moving at the same relative speed, such that the tracking of one includes the other. And before it's docked and it's just kind of sitting there waiting to orient itself in connection, you're saying the best we can get is post-connection. Well, I'm asking, well, if it took a certain amount of time where they shared the same orbital movement, but they weren't attached, and then they were, it seems like something reasonable that you could document.
There is stuff that I don't know if Astronomy Live himself documented it, but it has actually been documented where the space shuttle was approaching the International Space Station, but they were two separate objects.
Yeah, that seems. I mean, based on that size, I mean that's not half, but maybe a third. Absent this the
Well, you got to
solar
think
panels.
that the individual modules could fit within the payload bay. Once you assemble it all together, the whole thing as an assembly is going to be bigger than the space shuttle.
Is this a photo you're showing?
Yes.
Who took that?
Soyuz.
Oh, something next to it.
Yes, the Russians.
Is it as same size or
No,
slightly
no,
smaller?
absolutely not. You see that thing? Hang on. Okay, so
Yeah,
look
that little nub.
the
Yeah,
little nub to the
yeah,
not quite center, but more to the right.
yeah, yeah. I see it.
That's the Soyuz. That's that's the Russians.
Wait, no. Who took the photo? If that's the Soyuz, I'm asking who's at the vantage point.
The Soyuz. There's more than
Wait,
one.
there's a series of of nubs.
Yeah, because the international is actually, well, technically international, but it's actually more of a partnership between the Russians and the United States. And so when you have multiple spacecrafts coming in, there is a rotation, and as the rotation is happening,
Yeah.
you take photos
What
of
can
your.
you if the Soyuz is right there at that vantage point, why can't they just get the video I need like step by step right there, like
Well,
right
you
from
can
that
get the
angle?
video what you mean, from two
The angle.
spacecrafts docking at the exact same time?
Well, yeah, you're saying that Soyuz
You don't want
is
to
taking
have two crafts docking at the exact same time. That's very dangerous.
No, whoever took the photo, I'm saying that view right there is perfect. I'm asking why isn't that just a video, a full video where you see like within an hour of video or 2 hours of video, the space shuttle approaching the ISS, maneuvering itself to it looks like it was facing outward and upward relative to the ISS.
They do
And
have
attaching
video. They have it from the perspective of the space shuttle. They also have it from the perspective of the ISS. Which one would you prefer?
the Suez one.
This okay. Hang tight on that one. I will bring it up right now. Bear with me for a quick second.
Because that angle right there, it's like, if you're not going to use some sort of telescope to try to do it, which would verify it, like if they were both happening at the same time, like someone tracked those things pre-docking and post-docking, and then something more closer and local to the ISS was tracking the same exact thing.
All right, hang on 1 second. I gotta down the quality of this because I'm taxing out my internet here. So the quality might be potato here, but let's see if I can get this up. Bear with me for a quick moment. Boom. All right, so here's the Soyuz one that I've muted the audio because it's cancer, but this is a time lapse, so you can kind of see. Let me increase the. Let me move forward a bit here.
What is that flapping thing?
That's
on the right?
that's a communication disc. That's
Oh,
spinning, actually.
spinning.
Yeah, it's spinning, so it's a communication disc. This arm is going to retract out of the way. See, now what it's doing is it's coming into its docking point. And you remember that spot that we highlighted in the image?
The nub.
Yeah, the little nub thing. So it's going to turn into that nub momentarily. So you can kind of see as it goes in. Eventually, the space station at this particular point will go into Earth's shadow and it'll become dark. But what they do is that they spotlight the docking port so that the astronauts on board can guide it into where it needs to go. For the sake of time, I'm going to fast forward a little bit. Fast forward a little bit. Fast forward a little bit. You can kind of see the docking port right now, right there. And then it will dock right there. And then there's latching mechanisms that grab on and latch it into place.
Is it normal for footage in space to look identical to water?
It doesn't look like water to me.
It looks like underwater for me, but thanks for showing that. I appreciate it.
No problem.
Well, yeah, I would look at more stuff. I'll go follow Astronomy Live for his things. You
Okay,
know, just to
so
make sure I'm exposed to what you guys are appealing to.
cool.
Um,
Then I think what we should do is this. What we should do is that after you take a look at this 5 hour video and Godspeed if you decide to watch every single second of that because it is a lot of work to get through it. But what you would see at that point is the entire documentation of the manufacturing, the building, and the assembly of space station in that video.
yeah. What
After
was
that
that
is
link?
done, we will regroup and have another conversation.
Yeah, that sounds like a possibility. Can you send me or just name that one docking video? I don't know if it's some crazy link or
Just
something.
type in Soyuz docking, or you can type
Okay,
in like Russian, because the Soyuz is a Russian spacecraft. It's not American.
gotcha.
So that should if you look up a Russian space station docking, you'll find it on YouTube.
Okay, I'll look at that.
Cool. All right
Cool.
then. So what we'll do is, oh yeah, in the filmed one, let me bring this up real quick. Because I want to make sure that my audience, astronomy live. Bear with me for a quick moment here. Want to make sure I get the proper link. So this video was posted. Okay, so it's 5 hours and 16 minutes. Holy shit. That's dedication.
You could put it on like triple, right? Or
Yeah,
what's the
but it's
highest?
still 5 hours, even at triple speed. We're gonna be here for a while. What I
No, no,
did
yeah, we
was
wouldn't do that.
what
Yeah.
I did was I posted the link in my live chat. If you want to grab it from there, I'll also be sending it to you directly via Twitter DM.
Oh, that works.
So
Yeah.
you should have it in 3, 2, 1. So there it is. It's titled Construction of the International Space Station. And for your audience, you want to look for that on a channel called Astronomy Live. Repeat that. It is Astronomy Live. Name of the video, Construction of the International Space Station.
And then what's your channel name for my audience?
Red's Rhetoric.
That's REDS rhetoric.
Yes, RHETORIC.
Cool.
And
Uh,
there you'll be able to. I do videos with Astronomy Live too. There you can also find the video where I measured the altitude, size, and speed of the International Space Station. We use the moon as a backdrop. For people that have problems with that methodology, as flat earthers do, then you would want to look at Astronomy Live's video where he did the exact same observation, but without using the moon,
yeah. Yeah.
which
Gotcha.
nullified that argument against it for whatever reason they made it. But yes, so what we're going to go ahead and do, we will end this here. So I'm going to disconnect the call, invite some other people in to have a further discussion. You're free to come back later if you want, but we'll just check back later and schedule another conversation.
Okay, cool, man. I appreciate the conversation and all the exchange and the info.
All right, sounds like a plan. I will be talking to you in DMs.
Okay, cool. You send me that link in Twitter. You said, right?
Absolutely.
All right, cool. Thanks.
All right, bye-bye. All right, guys, that happened. I'm going to open up another call here momentarily so that we can, have more of a conversation here. And I just want to make something extremely clear. I know his position on the trans issues. I wasn't going to have that conversation with him. So don't get me wrong, guys. I'm as left as they come. So just keep that in mind. Holy shit. But I wasn't going to have that conversation with him. So anyway, let me go ahead and bring up another call, and I will post a link to you lovely people in the live chat, and we will do this again. Bear with me for a quick moment. All right, open up a new call. Bring that up. Okay, so I'm first going to invite the peeps, the bitches, and yes, maybe even some hoes. All right. And make no mistake, guys, he's not a flat earther. He is not a flat earther. That's probably why we've gotten this far. He is not a flat earther. I want to make that abundantly clear. He is not a flat earther. Okay, so let me go back to the main screen and we will bring this back up. Properties, I think it's this one. Yes, yes it is. Yes it is. All right, we should be back in biz. Boom. All right, there's the link, guys. Come on in, have a conversation. I'm going to grab a beverage and then we will continue this conversation. All right, we are back. Liquefied carbonated candy. Pure fucking fection. Anyway. Let me also send this link to people on the Twitters. All right, let's see. All right, the link has been sent out. I like drinking flavored sparkling water. That shit slaps. It's also not that terrible for you. Ah, come on. Where's the fun in that? Yes, Where's Wally? I did receive that DM. Also, Where's Wally? If you click that link, you can come on in and have a conversation. Yes, exactly. I wasn't going to have that conversation with them. I wasn't gonna have the gender debate with them. Just wasn't gonna happen. I know his position, and I know that was a surefire way to make this conversation turn to an absolute dumpster fire. I wasn't gonna have that conversation with them. So don't get me wrong, guys. Don't get me wrong, but I'm just not in the mood for that conversation. I wanted to stay on topic as much as possible. To give credit to Jim Bob, he's having a go at people in his chat. He doesn't like the way they behaved. Okay, so I'm going to need you to expand on that. What exactly is going on in his live chat? He doesn't like the way they behaved? How were they behaving? Like douchebags? What was going on? What did I miss? Because I didn't have his live chat up. I just had my own. And yes, I did survive. I survived. Don't know how I do these things, but I don't know. His chat was pretty bad. They were flurf talk. So they were of the conspiratorial mindset, I assume, or they were just filled with flat earthers. You're just anti-firmament. Well, they're not wrong. They are not wrong. I am very much anti-firmament because the firmament doesn't exist. I don't acknowledge something that literally does not exist. His chat is full of NASA lies and ask Fauci for a rocket booster. Why is it that every single time we want to have a conversation, like this happened with a ban notice on Twitter when I had my debate with him in that Twitter space. In a debate about geometry, ban notice could not help himself but bring up Fauci. Fauci being a douchebag has nothing to do with the shape of the Earth, nor did it have anything to do with this conversation. Fauci's not responsible for satellites being a fucking thing. People acting like children, taking the piss, bending the truth, some racist comments. Ooh, we had some of those. That's right. He's putting them in their place. Well, that's nice. I appreciate that from Jim Bob. Let's see. This discussion made me pretty happy. Been trying to get someone to talk to Jim Bob for a couple years now. Really? A couple years? Interesting. You know, from the beginning, I know that it was said that he wasn't a flat earther, and that's what initially made me curious about this guy as to how he's going to go about tackling this. And I think he's more of the, moon landing denial variety, and not necessarily the flat earther variety of conspiracy theory. So definitely not flat Earth. Definitely not flat Earth. I'm confident in saying at least that much. This dude is not a flat earther. At Red's right, the racism was when you were talking about the Chinese station. They were being racist against the Chinese space station, or the fact that China built their own space station? Like, what the fuck were they actually saying? Well, I guess I shouldn't ask you to repeat it because Google might get mad at you. But yeah, they were being racist against the Chinese because they have their own space station? That doesn't make any sense. If anything, it shows that the Chinese can engineer something like a space station. That's not trivial. That's pretty fucking awesome. You know, the more space stations we have, the better. Orion, and the basketball. One comment was, I don't own a basketball because I'm not black. Wow. Really? Someone actually said that? Did that actually happen? I don't own a basketball because I'm not black. Wow. Oh boy. Wow, 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 wow. That is, that's a comment. I bet they love their iPhones. Oh, man. The iPhone is a terrible device. Absolutely terrible. But that was actually, wow. Jim Bob says he is not a flat earther, but he uses their arguments like, how does the atmosphere not fly off into space? It's painfully ironic they deny the veracity of the science that enables their entire platform. Aside from the gender stuff, he's not too bad himself. I'm sure his sycophants are, but there are much bigger douchebags out there. I'd have to see the rewind to get the screenshots. Yes, if you can get screenshots, I would appreciate it. But the thing is that, and the one thing I do want to stress is that unless he explicitly says that he agrees with them, the comments made in his live chat should not immediately reflect his opinions on some shit. So just because someone made a racist comment when referring to basketball, that doesn't mean that he would believe that that comment was okay. So we can't immediately jump to conclusions like that, and I would warn against such things. And you're right. Besides the gender stuff, which again I'm going to do everything in my power to not get into, because I do not want to fucking have that conversation. We're talking about space, satellites, that kind of thing. Let's try to keep it on that subject, time and place kind of thing. Besides that, I think it was a good convo. I think it was a lot better than the convos I've had with flat earthers in the past. All my convos with flat earthers turn into some flavor of dumpster fire. I don't think this was a dumpster fire. This was more of a dumpster smolder. The dumpster was starting to billow some smoke, but there was no open flame. You know what I'm saying? So, progress. We're making progress, I think. So, I mean, if I could take a smoldering dumpster over just a full-on inferno, I would. So guys, I'm going to give you guys one more chance to hop into this call if you so choose. Same thing for Where's Wally on Twitter and all the other people that I sent the link on Twitter. I'll give you guys 5 more minutes, and then I'm going to go ahead and conclude this live stream. At Red's Rhetoric, his first insult to someone in his chat was to call them a woman and for getting emotional as they were annoyed at his stupidity. So only women have emotions, okay? At Red's Rhetoric, I don't think he saw most of it. The mods were doing a good job, and I got to interact with them never again. Oh, so it was that kind of experience, okay. Orion, I would join if I could, but I am writing a chemical report at work. Multitask. At Red's Right, it's really not letting me join, at least me personally. Ah, man. Gotta fix your shit. Call Nathan Oakley. Yeah, I'm not calling Nathan Oakley. I want him to continue running away for a little bit longer. Like, let's see. Where are we at with... I did so a few days ago. It was... so Nathan Oakley has been... Let's do this. Nathan Oakley has been refusing to debate Red's Rhetoric on a neutral platform for 1,991 days, 17 hours, 48 minutes, 6 seconds. Love it. Absolutely love it. Only a few more days until we hit the big 2,000. Only a few more days. Oh, we're almost there. And then we're going to have an absolute fucking party. It's going to be awesome, guys. Oh, we're so close. Moto Kid at Reds, just tuning in. Can we get a quick summary? Yes, I started this live stream. Some stuff happened, and here we are. What time is it there, though, Reds? It's only 9:30 p.m. here in the UK, and you're usually on later. It's currently 4:48 p.m. 4:48 p.m. right now. And the reason why I'm on early is because he chose this time. He said he would be available at this time, and I will make time for someone who's genuine about having a conversation. I will make time. I'm very fortunate to have that level of flexibility. So this is why I came on a little bit earlier than I normally do. Usually I try to start my live streams at around 6 my time. That's when I would be most comfortable doing a live stream. But he said he wasn't going to be available at 6 p.m. So he said, "Can you do 2:30 p.m. instead?" And I was like, "Sure, we can make that work." So we made it work. And yes, East Coast rules. Eastern time zones is the time zone. It is the ultimate time zone. Everything else is a mistake. Damn the Earth for being round, right? That fucking round Earth with its fucking time zones and shit. There was a promise of a docking video. I guess they were disappointed in Red's vid. I see what you did there, Dora. I see what you did there. If you know, you know. If you know, you know. Giggity, giggity goo. Center of the universe, yes. The turtle moves. GMT plus BST is much better. It's right, turtle moves. You're allowed to be wrong. Roger that. That's on Red's OnlyFans. Yes, it's my OnlyFans, except it's just pictures of my feet and armpit. Alright, guys. So, given that no one showed up to continue the chat, which is probably a good thing because I'm tired, I'm going to go ahead and end this stream. So I do want to say thank you to all of you who tuned in to watch. It means a lot to me. Thank you very much for leaving a like, and to all the new subscribers, welcome. Glad to have you on board. We're going to have more conversations in the future. I'm trying to get a few more flat earthers onto the show. Who knows how that's going to go. It all depends on how brave they are. And apparently we're going to have another conversation in the future. With our previous guest that we just had. So I do want to say thanks to him for getting ready, or being prepared to have another conversation, I should say. So we'll see if he watches that 5-hour long video. Godspeed if he does, because that is dedication right there to watch 5 hours worth of content. So we'll do that. But yes, I'll keep you guys updated every step along the way. Just follow me on Twitter if you want to stay up to speed on what conversations are going to happen in the future. And I would very much appreciate it. At Ryan at Reds, thanks. Would love to join at a time where I wouldn't freak out people sitting at the desk beside me. Yeah, that's fair. You know, all of a sudden it's OnlyFans that has to do with feet. Yeah, it would be quite uncomfortable for the people sitting right next to you. Or it could be totally fucking hilarious. Depends on how you view humor in our modern day society. Anyway, so guys, thank you very much for watching. I appreciate you. And with that,